Hello everyone and welcome back to the Pondering Philomath. In today's video I will be teaching a technique for finding the squares of some special numbers. But before we commence with that, I will quickly just show the answer to the question that I'd asked in the last video, which was the video where we multiplied by 11. So the question was, how do we find the answer to the following problem? We had 19,347 multiplied by 11, right? So let me just quickly show it to you. You're right. How do we do it? We just copy down the 1 and the 7 from the question as it is. And then 4 plus 7, which is 11 with a carry 1. 3 plus 4 is 7 plus 1, which is 8. 9 plus 3 is 12. So that's a 2, carry 1. And 1 plus 9 is 10, plus the carry, which is 11. Again, as it's 11, we have to carry a 1 over here because the 1 was already here since before. And we get the answer, which is 212,817. Quickly check that again. So we had 19347 times 11, 212,817, right? So we got the correct answer. So that's it. A pretty simple calculation, even for such a large number like this. So if you want to learn this technique in more detail, you can find the link in the description box down below. But right now, let's move on to finding the squares of some special numbers. Right, so the first case that we're going to look at is finding the squares of numbers which end with a 5. So, squares of numbers ending with a 5. Examples are, for example, 25 squared, 35 squared, and so on, right? So the number has to end with a 5. And we start off with a simple example, such as 15 squared, right? The answer, I can tell you, is going to be 225. And how do we get to that? I'll just write down the question here again one more time. And what we do is first, we write down the 25 at the end of our result, right? So this is the last part of our result. And the beginning part, how do we find that? Well, we see that the other digit, apart from the 5, is 1. And now we carry out a multiplication. So we do 1 times 2, because 2 is the next number, right? So 2 comes after 1. So we just do 1 times 2, which is 2. That's it. Super easy. Let's try with 95 squared. So we, again, do the same thing. We write down 25 at the end of the result. And then the other number is 9, so the number apart from 5. It could be 10, it could be 11, however many digits. But to do it mentally, let's just take 9. 9 times 10, so 10 comes after 9, so that's why 9 times 10 is 90. And this is our answer, 9,025, right? So that is super easy. And in fact, this is actually a special case of a more general trick that we're going to look at now. So the general case that we're looking at now, it has 2 conditions. So the first condition is that the last digits of the number that we are multiplying have to add up to 10. Add up to 10. What do I mean by that? For example, whatever numbers that we are multiplying end with 1 and 9, 2 and 8, 3 and 7. So all of these last digits add up to 10. And the second condition is that all of the other digits, well, they have to be the same, right? So yeah, these are the 2 conditions that have to be upheld. So let's start with an example. We will look at 91 times 99, right? And let's just see if the conditions are being upheld or not. We see that the last digits, which is 1 and 9, they add up to 10, right? 1 plus 9 is 10. And all of the other digits, in this case, which is this 9 and this 9, they are the same, so it's the same number. What do we do in this case? We take the last digits, which is 1 and 9, and we multiply them, which is a simple multiplication. So that is 0, 9, right? 1 times 9 is 9. And you have to be careful that we have two digits, that we use two digits over here in our answer, even though it's actually just one digit. But don't forget the 0 over here. The next thing that we do is a similar multiplication that we did over here. And so we multiply 9 by 10 because it's the next number, right? So 9 times 10 is 90, and we get our answer, 9009. So this is the answer, and this is the general case, and this is the special case, right? And why is it a special case? Because the last digit is always a 5, right? And if we're squaring it, then the last digits add up to 10, right? And all the other digits are the same because we're squaring it. So this was the first technique. And now the second technique that we're going to look at is also for, well, it's squaring numbers, which lie between 50 and 60. Right, so this is another special case, and let's just dive in with an example. Suppose we have 52 times 52. We're squaring it, right? So it's the same number. And here what we do is we just multiply the last digit, which is 2 and 2, multiply it like normal, and we know that it's 4. And don't forget the 0 here, just like here, right? So it's a 2-digit answer for this multiplication. So it's a 0 and 4. And for the rest, what you do is you write 25 plus the last digit. And the last digit in this case is 2. So this would be 25 plus 2, which is 27. And that is the answer. Right? So this is also quite easy. That's the point of a trick. Yeah, so I hope you understood all of these tricks. If you have any question, then feel free to write them in the comment box down below. And if you want to practice, then I can give you a few questions that you can try these tricks on. So for the first one that we learned, squares of numbers ending with a 5, how about you try squaring 115? And in this, well, while calculating this, you can also use the previous video with multiplying by 11 as a trick to make the calculation a little faster, right? For the general case, you can use, or you can calculate 86 times 84. And the last one, squaring a number between 50 to 60, how about you try squaring 59, right? So you can post the answers down below in the comments box, and if you have any questions to how to solve them, you can again post them in the comments box down below. If you like the video, then don't forget to press like, share, and also subscribe to learn about more such tricks, right? So that's it from me, and yeah, hope you come back to the Pondering Philomath.